So this is a bit of an ad hoc video. We're going to look at some of the modules that went to Bricks by the Bay and see how they fared. Most of these modules were built during COVID and they never really ran for a full 2 or 3 day show. And subsequently, they haven't had that much real debugging. So we'll look at the ones that need repairs and also the ones that did well. So let's start with one of the smallest modules, the split level stepper. Now, this module actually ran fine mechanically. It just had the misfortune of being stuck behind two very fast modules that didn't buffer any balls. So it would often get more than 30 in the input, and that would overwhelm it. To solve this problem, at least temporarily, I increased the gear ratio from 3 to 25 to 1 to 5, but that really just pushes the problem down the line. The more interesting thing about the split level stepper will be to see how much dust has accumulated on all the steps and the gears. So here are the steps from the split level, and they look about as bad as I would expect. You do have to remember that the split level has run a lot in the past, so some of these parts have already worn down such that they're smoother than if they hadn't run at all. More noticeably, perhaps, are the little splotches of purple, and I can't entirely tell if this is just grime buildup or the paint coming off the balls, or perhaps a mix of both. This is most obvious in the shell, and you can see all the places where balls rolled around obstacles and I guess rolled over edges. But yeah, all this module really needs is a bit of dusting and it'll basically be fine. The Peaucellier Lift also had basically no mechanical problems. And unlike the split level, the high capacity means that it didn't get overwhelmed as well. In a show where modules could have run up to, say, 16 hours on both public days, the Peaucellier Lift probably got close to that. And in fact, it even won the Lovely Linkages Award. One thing to note is that because of how well balanced the mechanism is with the additional counterweight, there's very little wear on the drivetrain. I don't know if it's easy to see, but there's not much dust on that gear inside that gearbox, nor is there much dust on the two gears in front. The not Scissor Lift is the first of the more problematic modules. Now, this is V2. V1 actually ran at Bricks by the Bay in 2019 with pretty good success. So I originally had high hopes for this. And this has worked reliably on a limited basis in the past. However, after just a little bit of running, this platform stopped unloading large batches properly. And I'm not entirely sure why this is the case. You can see I added these reinforcing bars here because I thought this platform might have shifted, but people who have tried to build this from the rebrickable instructions have reported problems with making it work. So there might be something systemically wrong with it. So the slide and spin ran with the extensible chain lift, and both of these sides had their fair share of issues. The chain lift always had a suboptimal input, let's say. Even with the agitator, it could fill up and balls could arc and get stuck or whatever. During the con, I did find out that using the tooth for the agitator is not very good, because the shape of this tooth just like bumps balls up and it doesn't actually agitate them. A 3-length lift arm is actually a lot better, and even though it will pop balls occasionally, I think I will switch to this and see how it goes. On the actual slide and spin side, this is actually pretty reliable, except that after running for a while, this switch starts to build up more friction, and it also loses the detents. Everything just kind of wears down, and it'll stop switching reliably. What probably needs to happen is that rather than just have this small weight here, it needs some sort of spring to make sure that the switch will, go to this side or this side and not somewhere in the middle. Now, the lift side didn't seem to develop that much wear, but on the sliding side, you can see this gear and this entire gear train was perhaps not very happy. This may be the highest friction point in the whole drivetrain, because this is where the sliding platform needs to stop and reverse, and so on and so forth. The slide and spin also won an award for Best Brickheads, and I'm pretty sure this is because all other Brickheads models were just static models. So the Auto Dozer, it had one big meltdown on the first public day, and it was actually the hardest to debug. Now, I wasn't there when it broke, so I couldn't see what was the problem, but when I came back and I was trying to drive the mechanism, it seemed like the tower was jamming. But after I took the tower off and I was cranking the thing over, it felt fine, but then every time I put it back in, it would start jamming again. And eventually I found out that what had happened was this entire axle had like walked forward. So when I connect the tower, when I connected the tower like that, the axle would jam with the crank, and I couldn't tell because it would only happen once the two things were together. The gears walking was kind of a theme with this, in fact, because after I pushed that axle in more, it didn't walk anymore, but there were some other gears, like here, that would keep walking off, and that would stop the boat from traversing the arena. And this module has some pretty intense dust buildup on some of the high speed and low torque shafts transmitting power to the boat. The loading tower here, more so than most other modules, is also full of that ball debris, and you can see it there and all the way down there, and also on the core. And it's basically anywhere that balls impact, it seems. It doesn't even need to be vertically like on the tower, because these are side impacts.
So I revamped the popper before Bricks by the Bay, and we had to rebuild it a bunch on the first day due to some bugs. The main way the popper fails is that the popping arms, if they didn't retract fully after they finished popping, the cams that push on them could jam against it. So we had to lower the support here so that it's actually not possible for the popper arms to go up any farther than that now. That prevented any jams, but now the module explodes if you run it backwards, so I still need to add a one-way mechanism to the motor. We didn't have enough reversing switches, so set it up like this. If you need to run it with a different polarity, you move the motor over to here and press into the other gear, and now I'll run the other way. I expect this module to generate a lot of dust due to the sliding movement and the fact that the rubber bushes are absorbing the full impact from the popping. In fact, when I rebuilt the module, we already saw a little bit of wear. So let's take a look at how much dust was generated. So you can see there's a lot of crud on some of these cams. And let's take a look at how the bushings fared. The other thing that happened was partway through the show, I saw these popped up a little like that because the spring force pushes up on this entire assembly. These swung down like that. So there's a lot of dust here. It's black. ABS dust is almost always gray. So I'm pretty sure this is flakes off the rubber bushes. You can also see that the spring arms have a little bit of wear on them. Basically exactly where the lift arms push. I'm almost certain they're worn a little because some gray dust was left behind, but it's not obvious from shining light on it that there's an issue. But you can see that every single popper arm has a wear mark. Gears themselves look fine. They aren't really heavily loaded at all, so I bet this 12-length axle will have a little bit of dust on it, but it's supported in a lot of places, so maybe not. So all of these rubber bushes have a wear mark here, and it doesn't take up the full width, which is kind of interesting because the way they're installed, the flipper arms won't hit them on that side. But here's the culprit. The lift arm that presses down actually touches them briefly before pushing down on the flipper. So that's a bit of a weakness in the design. That's probably where most of the dust has come from, actually. I built this Dozer module before Bricks by the Bay, and it performed fairly reliably there. The only problem we had was we forgot to plug it in once, but other than that, there weren't any jams. Despite that, there's two weaknesses and two sort of learnings here. The first is that the module's flat on the bottom, and because it's flat on the bottom and completely smooth, it's pretty easy to knock the module around by accident when you're moving other stuff. And this might cause it to not line up with the next module and spill balls onto the table. So one thing to do here might be to add some feet or tires, some friction material to keep it from moving around so easily. The second is that the output is a little low. This trophy is 10 tall, and you can see it's slightly too low. And also, this isn't secured to anything, so a couple of times we had this tip up like that, and that causes balls to get spilled here instead of going on to the next module. When I redesign this module, probably what I'll do is raise the output by a brick, so that'll mean I have to change the linkage. And I was going to change the linkage anyway because I want to use the newer version of the digger bucket, which doesn't have these thin arms and has some studless beams there instead. Other than that, this module doesn't really have much dust on it. I assume if I keep running it, I'll get dust in the usual spot on the worm to worm gear interface and on either side of the worm. I expect to see dust. Probably just this side, honestly. And maybe a little bit on the pins. And there's a little dust on this module in places I didn't expect. Inside the digger bucket, there's some tracks, probably left over from balls rolling around in there like that. And there's a similar track here on the input bin, exactly a ball's width away from the side of the wall. So I can't tell if that's this wearing or if that's dust from elsewhere in the loop that the ball's carried over here and deposited on the module. Either way, pretty happy with it, just need to adjust the parameters of this linkage. So this is Pancake Flipper, which is my oldest module, and basically the only revision it received before the show was that I changed the choice of lift arms here for guiding the output. Again, not too much to go wrong on this module, fairly reliable. There's a couple of operational gotchas. One, this module is also flat on the bottom, and it's very light, so also very easy to accidentally bodge it and make it not line up with the next module. So the other weakness with this module has to do with the loading mechanism. When the arm's all the way down and the gate's fully pushed down, there's nothing here that keeps balls from overshooting, so that can happen. Right? If the balls come in slowly enough, it's fine, but fast balls will overshoot. And it's pretty normal after running for a while to find a bunch of balls accumulated there on this module. And so probably what the correct fix for this, there's a couple. I could try to slow the balls coming in, but really I should have a mechanism similar to this on the Dozer, where only a few balls can load at once, and that'll put a stop to that. Again, this module accumulated a bunch of dust inside the loading tray. You can actually see the path the balls take. Either they're going here and bouncing around, or if a ball's stuck there, they're bouncing off their neighbor and going around. And then inevitably there's 3 or so of them waiting here. What's weird is that this dust is purple, and I wouldn't expect that because nothing's purple on this module, and usually ABS dust is gray. But we did use these kinds of balls during the show, and maybe it's that printing wearing off gradually, and this dust just comes from somewhere else in the layout, and the balls leave it here as they go by. So this elevator module is actually kind of old. I built it before Bricks by the Bay 2019, where it actually won an award for using string. And before this year's show, I made a couple of adjustments to it based on problems I've had with it in the past. Brief overview, the way this module works is there's a motor that plugs into a differential, and the 2 outputs from the differential go to the winding spool that controls the elevator and a pole reverser. When the elevator reaches the top of the travel, the spool jams and the output goes into the pole reverser, which changes the direction of the motor, causing the elevator to reverse. At the bottom of the travel, the spool runs out of string and winds back up the other way. So every two times the elevator goes up, it flips the pole reverser back and forth once. To load at the bottom, the elevator has to stop not too far down, otherwise there'll be too much string, and not too far up, otherwise the gate won't open enough. To control that, I let out or take in some string on the spool. Previously, this spool was located here and wasn't very tight, and it was very easy for the wrong amount of string to come out. I moved it here and put it on one of the new double half pins, so it's 2 friction sections and 1 axle section. And then it pops up here and winds around this pin 4 times. that uses the capstan effect to amplify the holding force on the other side. So this won't unwind during the show, basically. The other thing that would happen with this module after running it a while was that the switch would get stuck in the middle position like this. That shuts the elevator off, and it won't do anything until somebody comes by and whacks the switch over to either direction. Before this show, there was no spring here, and so this polarity switch is quite worn at this point, and it's very easy for it to get stuck in the middle. So if you build a module like this, you really need a mechanism to force the switch to one or the other side. This shock absorber is just about the right length. It's very lightly compressed on either side and more heavily compressed in the middle, so it's really reluctant to stay in the middle at this point. Other upgrades for this module before the show were more about reliability and structural strength. So the shaft that holds the spool and this clutch gear is held on by more studs now. The other change was to make it easier to change the height of the elevator. So the way the elevator stops is that it jams into the top of its travel, and then the door opens with this gear. When this gear turns, it lifts the rack attached to the door and opens the elevator, which unloads it. That's done by these other gear racks here. And so the change I made was to mount this and the top stop on the same frame. So now you can change the height of the elevator by pulling these gray pins carefully. And then you can just drop the ceiling to whichever height you like and put the pins back in. The main problem is I didn't remember to attach the output ramp to the same unit, so you still have to move that separately. So after this, I'm going to go rebuild it. So the output ramp and the top and the door opening mechanism are all part of the same unit, and you can easily adjust the elevator's height up or down. This is Grab and Spin, which is a module you may have seen a couple times in the background of other Nonsense Wars videos. It's been temperamental since I built it. It's actually about the same age as the elevator, so I've had it for about 3 years. And it uses the same core mechanism. You can see that there's a differential cage here, and underneath the loading ramp there's a polarity switch. So it's the same mechanism. When the motor runs into either hard stop, it reverses itself. There's just some additional complications on top of the elevator's design. First is that the mechanism that flips the switch also raises and lowers the input. The second is that the other output is this under-actuated arm. It turns this, it will attempt to open the arm, and when it can't open it any further, it will turn the turntable, which is not actually powered by anything. And in the other direction, it will close the arm, and when it can't close the arm any further, it will turn the other way. So that's how this module works. It closes the arm, turns all the way here, and then it jams, so the motor reverses. It opens the claw, it turns the arm back, it pops this up, and then it jams, and then it'll reverse, and the cycle will run over and over again. So lift, close, turn, open, turn, down, and over again. So there are only 2 minor edits I made to this module before I brought it to the show, and even then it didn't quite work right, so I actually did not register it for Bricks by the Bay. I brought it to use in a unreliable modules loop, but had to subs it in when another module failed early, and it ran the entire show without any real problems, so I'm not quite sure what to make of that, if I just shouldn't try to fix anything that seems broken at this point, because it does appear to work. But that rubs me the wrong way. The only changes I made before the show were to add some reinforcement to this section here. The rubber band here performs the same function that the spring does on the elevator. It keeps this from being stuck in the middle position because the rubber band adds some resistance. So that's the only function of that. The other is that because this module works by turning the arm into the hard stops suddenly on either side, it can gradually drift. And I added these tires at the bottom so that the module is, these don't turn, the module is reluctant to slide around. And that made a pretty big difference because normally the module would unalign itself after a while, and it didn't do that at all this time. And I'm actually pretty pleased with these wheels in particular. They're pretty small and the friction coefficient is pretty high, so I'll probably add them to my other modules as well. This module is pretty hard on the motor and all of its components just due to the underactuated mechanism here and the fact that the motor is constantly being slammed into hard stops. And so you can see there's quite a bit of dust here where the motor was. The mounting of the L motor may have also played a part because I noticed just now that this was being pushed off to the side. I think there's a little bit of dust here, but actually less than I expected. So it's really all concentrated here. I wonder if that's because of the stress on this module or the wrong orientation of the L motor. The other obvious place for dust, of course, is probably on either side of the lifting mechanism here. I don't think I have a good way to get access to it quickly, but any slider that's sort of constrained like this is a recipe for generating tons of dust. Again, there's also the purple dust that we saw on the other modules, probably just picked up from elsewhere by the balls we used in the show.